Um, and we can approximate that with the normal, with mean 3.5 times n, where n is the number of rolls, and variance 35 divided by 12 times n.
Okay, so say that again. What's your setup for the random variables themselves?
For x,
Yeah, X is the sum of the rolls, right?
mm-hmm.
Okay. So, I mean, that's some unspecified number of rolls, right?
Right.
You know, X, N, whatever
Mm-hmm.
it happens to be. And you said a die is continually rolled until the sum of all the rolls exceeds 300. Yeah. So what are you saying? Say it again.
Well, so for any one of the xi's, they're going to have a mean of 3.5. So x is distributed as approximately as the normal, with mean of 3.5 times n and standard deviation of 35 divided by 12 times n.
So X itself.
Right. Yeah.
X itself is kind of like, that's like the total, right?
Mm-hmm.
Sample total. So this is approximately normally distributed
Mm-hmm.
with mean equal to the same as the mean of the xi,
Mm-hmm.
which is 3.5. And what?
Well, 3.5 times n.
Oh, right. Right. 3.5n. Yes. And then what? What's the
Variance.
deviation?
What?
What's the standard deviation?
Standard deviation is square root of 35 divided by 12 times the square root of n.
Okay. Okay, so that's what you have?
Yeah.
All right. And then what? Tell me what you did next.
Well, so Matthew suggested, so that basically, so it says the probability that we need at least 80 rolls for the sum to exceed 300. So we're looking for the probability that x is less than or equal to 300 if n is 79, sorry.
Okay. So I'm going to call this random variable y just so we can reference it. It's not exactly the same as x, right?
Right.
But it has a, you know, asymptotically the same distribution. So you said the probability, so say that again.
That y is less than or equal to 300.
Mm-hmm.
Where we plug in 79 for n.
Okay. Right. So if
But
n,
that doesn't quite work because of the continuity correction.
okay, so that means that, you know, if we do 79 rolls, then that's true.
Mm-hmm.
Okay, so the probability, yeah, okay. So this would mean that it's going to take at least 80 rolls. So that's exactly right, right? So this would mean that it would have to be at least 80 rolls. This happens if and only if it took at least 80 rolls for that to occur, right?
Mm-hmm.
So I mean, here's what's going on. So x1 plus dot 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 plus x79 is less than or equal to 300 if and only if what? It takes at least 80 rolls to get X greater than 300, right? So yes, this is exactly the probability that you want, but this, you know, so probability, so really what you want is you want the probability that X1 plus dot 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 plus X79 is less than or equal to 300, right?
Mhm.
But you know that this is going to be well approximated by, because of the continuity correction, the probability that Y is what? Less than or equal to 300, 300 what?
0.5?
Yeah. And does that give you the right answer? Or no?
I have it up on Excel, I can check.
Did you, I mean, did you put 300.5 in there?
So I just did, and it's definitely, yeah, it is, once you round. Okay, yep.
Okay. What do you end up getting if you plug that in?
0.9431 once you round.
Okay. And is that what's the, is that the answer in the back of the book?
Mhm.
Yeah. Sometimes it's a little bit annoying because you'll have a situation where it doesn't really make sense for the original variables to be negative. And then you do a normal approximation by using the CLT. And then you're like, what is going on? I'm not getting the right answer. It doesn't make sense. And it's because you have to remove negative stuff. Okay. So that's another thing that you might run into from time to time. But yeah, the continuity correction is a typical thing you have to do in the discrete case. It's fairly annoying, but you know, you just go up by a half unit or down by a half unit if necessary on the other end. If you have something equal to or greater than something. Yeah. Okay. Good. So does that kind of answer that question then?
Mhm. Thank you.
All right. Anything else? What other questions do you have? What else? There's one example in that lecture from several weeks ago that I told you guys to check out, you know, if you really want to understand some applications of the central limit theorem, where I said you couldn't do something. Do you remember that? It had something to do with rivets. I don't know if people saw that or not, but it had something to do with rivets. And I said you couldn't really answer the second question. And the reason you couldn't was because you don't know the underlying distribution for individual samples. Like if I take an individual thing out, I don't know what the distribution of that thing is. Yeah. All I know is if I take a big sample and ask a question about the sample mean, then I can invoke the central limit theorem. And that's kind of the main point that I was trying to make. Like, you know, jack squat about the individual data values. You don't know anything. You don't know what the distribution is. So you just simply cannot answer a question about an individual data point unless you knew what the underlying distribution was. But the amazing thing is, even if I don't know the underlying distribution, if I ask a question about X bar, I can answer it because of the central limit theorem. That just seems impossible, but it's true. So it's just an amazing thing. It's a huge probabilistic weapon at your disposal. Okay. Any other questions? Any other questions? So did you guys get all my comments on your projects? That come through all right? I think was it Elise and Katie, were you the ones that I was saying, be careful about those inner
Yes.
integrals? Did that make sense to you?
Mhm.
Mhm.
Like you had integrated out the inner variable also, and that wasn't necessary, right?
Right.
Mhm.
You think of those as being fixed, but yeah, just want to make sure you guys understood my objection to that. But yeah, that's like an important little tidbit for sure. Well, you guys have any big things going on this week? Any big finals?
My biggest one is just I have my linear algebra one tomorrow, so
Is that
that'll probably be
live?
the biggest. No, we have 3 days, 2 days to do it. I think it's due
Okay.
Thursday, but he's putting it out tomorrow. So
Okay. All right. Well, hey, it's been a pleasure. It's been fun talking to you guys about some probability. I wish I was doing the math stats class, but I don't know if I am or not. I guess I don't think I am. I don't know when that is even offered next. When is that offered? Next spring or something?
next fall, because it's fall of my senior year.
Oh, okay. So it's not this coming fall, but the fall after next?
Mhm.
Okay. Yeah, we'll see. I don't know. I've never actually taught that class before, but I think I know the material. It would be interesting to kind of go through and the textbook that's used and see what sorts of things are emphasized in there. But yeah, it's been fun. Thanks for being a lively bunch. And hey, if you haven't gone and filled out those evaluations yet, go ahead and do that. Appreciate that for sure. All right. Anything else? Well, hey, take care, everyone.
Thanks so much, Dr. Hammett. It's been
Yeah,
great.
yeah.
Dr. Hammett.
Yeah, no problem. No problem. All right. See you guys.